Hello and welcome to the TechBits YouTube channel. In this video, we're going to be discussing about Postgres table indexing, how it can improve Postgres query performance with table indexing. Utilizing table indexing in PostgreSQL offers several benefits and plays a crucial role in improving query performance and data retrieval. Here are the key reasons for utilizing table indexing. First one is faster data retrieval. Indexes provide an efficient way to locate and retrieve data from tables. They act as a roadmap, allowing the database engine to locate specific rows quickly based on the index columns. By utilizing indexes, you can reduce the need for full table scans and retrieve data in a more efficient manner. Second, improve query performance. Indexes enhance query performance by optimizing the execution plans generated by the query optimizer. With properly designed indexes, the query optimizer can choose the most effective access path and join strategy, resulting in faster query execution times. Indexes enable the database engine to narrow down the data search space, reducing the time required for query processing. Sorting and ordering. Indexes are beneficial for sorting and ordering operations. They allow the database engine to retrieve data in a specific order, based on the indexed columns. This eliminates the need for manual sorting or the use of additional sorting operations in queries, leading to improved performance for sorting-intensive operations. Join optimization. Indexes help optimize join operations between tables. By indexing the join columns, the database engine can perform efficient join algorithms, such as index nested loop joins or merge joins. Indexes on join columns can significantly improve the performance of queries involving table join. Constraint enforcement. Indexes play a role in enforcing unique and primary key constraints. PostgreSQL automatically creates unique indexes for unique and primary key constraints. These indexes ensure the uniqueness of data and enforce the integrity of relationships. By utilizing indexes, you maintain data consistency and prevent duplicate or inconsistent data. Full text search. PostgreSQL offers specialized index types, such as full text search indexes. These indexes facilitate efficient text search operations, allowing for advanced search capabilities, ranking of search results, and efficient retrieval of relevant text-based information. Aggregation and grouping. Indexes are useful for optimizing aggregation and grouping operations. When queries involve aggregate functions, grouping by specific columns or indexes can significantly speed up these operations by providing fast access to the group data. Data and integrity and consistency. Indexes help maintain data integrity and consistency by enforcing referential integrity between tables. By creating indexes on foreign key columns, you ensure that the relationships between tables are properly maintained. Indexes assist in preventing the creation of orphaned or inconsistent data. Okay, it's important to note that while indexes offer performance benefits, they also come with performance overhead. Indexes consume also additionally disk space and require maintenance during data modifications. It's also crucial to carefully consider the columns to be indexed, the index types, and the appropriate indexing strategies based on the specific workload and querying patterns in your PostgreSQL database. Let's go ahead and head straight into a demo of multiple types of indexes that are useful. So let's head into psql. First, I am the Postgres admin account here. I'm going to go into psql. Notice I'm already into PostgreSQL command line and version 13.12. Let's go ahead first and create a database. Let's name it my table indexing. It already exists, so let's drop it and recreate it. Now let's connect to it. We are now connected. Let's create a simple table. I'm going to copy and paste SQL statement. Notice it's just a simple table, employee with ID, serial primary key, first name, last name, email, age, and hire date. So the first thing is we're going to create an index on a single column. In this case, it's the last name, and that's the column that we're going to leverage. The next one, we're going to create a unique index on another single column, which is the email. And then we're going to proceed to create an index on multiple columns, which is very useful. Last name and age, just as an example. Nothing really to it. Then a partial index. Partial because it is created on the age column itself from the table employees, where the age is less than 30. So not all the tables going to be having an index unless they meet the age requirement of less than 30. And last, we're going to create an expression index. Expression because it has two columns. Notice the space between the first name and the last name. Now, this is all good that we can see we created the indexes, but you're probably thinking, how do I know they were attached to the table? Or where are they? Well, first, let's take a look at the tables that are available. Let's describe the employees table. Yes, it's not always that useful, so let's change this strategy to expand the display and repeat the process. We notice that we have employees, key, indexes here attached. An easier way to find your index is PI. And here we use the extended display. Notice that it has the first record, the employee's primary key, then the other index. Email that we created, the full name, the last name, available there to us. And that is how you create other indexes. Hopefully this video was of usefulness for you and you learned something on it. Stay tuned because we have more videos coming out, also book reviews. And don't forget, if you have a topic that you'd like to be addressed or mentioned, we can explore it and help the community. That's it. Stay tuned. See you in the next video.